This bioluminescent lure draws curious prey into the darkness. This bioluminescent lure draws curious prey into the darkness.
In the pitch black of the deep ocean, life has evolved its own light. In the pitch black of the deep ocean, life has evolved its own light.
At these extreme depths, sunlight is non-existent. Here, life generates its own light to survive. This bioluminescent lure draws curious prey into the darkness.
Near the surface, sunlight fills the ocean with life. But as we descend, the light quickly fades away, entering a world of perpetual darkness. Near the surface, sunlight fills the ocean with life. But as we descend, the light quickly fades away, entering a world of perpetual darkness.
In the deep ocean, energies develop luring mechanisms. Others must face the void of absolute scarcity. This balance dictates survival. Beyond the famous lure lies a complex machine. Its specialized jaw unhinges to swallow prey whole. An expandable stomach allows for massive meals. Beyond the famous lure lies a complex machine. Beyond the famous lure lies a complex network of sensory systems. In the absolute dark, every input is vital, including a bizarre method of reproduction. Beneath the surface lies a hidden anatomy. Internal systems defy typical vertebrate structures. A physical fusion ensures survival in the deep. At this level, physical borders begin to dissolve. Individual identity gives way to pure genetic code. A flow of biological data dispersing into the void.
In the deep ocean, bioluminescence is a known tool for survival. But what happens when we encounter structures that defy our understanding of marine biology? Millions of years ago, ancestral fish began a remarkable transformation, driven by environmental pressure and genetic mutation, culminating in extreme deep-sea adaptations. Bioluminescence began a marca fish.
We often project hostility onto the deep ocean. But it is not actively aggressive, it is fundamentally indifferent. Exploring this void presents immense challenges. The absolute absence of life reveals a chilling isolation.
At these depths, life is sparse, driven not by struggle, but by pure indifference.
At these depths, the water temperature stabilizes, hovering just above the freezing point. This thermal map reveals the absolute uniformity of the abyss. Descending through the water column, pressure increases. Abstract shapes deform, as depth increases, reveals the only specialized life survives. In the deep ocean, energy is the rarest commodity. Life here has evolved to survive on mere specks of light, waiting weeks or even months for a single meal. In the deep ocean, energy is the rarest commodity. Life here has evolved to survive on mere specks of light, waiting weeks or even months for a single meal.
In the deep sea, energy is a priceless commodity. Missing a meal can be as fatal as becoming one. To survive here, form follows function with absolute precision. The jaw expands to seize any opportunity, extends to hold massive prey. The deep-sea anglerfish possesses a jaw perfectly adapted for the pitch-black abyss. Its inward-facing teeth act as inescapable hooks. The deep-sea anglerfish possesses a jaw perfectly adapted for the pitch-black abyss. Its act as inescapable hooks. The deep-sea anglerfish possesses a jaw perfectly adapted for the pitch-black abyss. Its act as inescapable hooks.
How does life survive in a vast, empty abyss? Where meals are rare, adaptation becomes extreme. In the food-sparse deep sea, survival requires extreme adaptations. An enlarminess of meals, perfected for the dark. In the absolute isolation of the deep ocean, life has evolved to its most reductive forms. Every feature is designed strictly for survival. In the deep ocean, life is defined by scarcity. Creatures evolve to conserve every energy event. In the deep sea, meals are rare. Predators must maximize every opportunity. Enormous jaws allow them to swallow prey larger than themselves. Beneath the surface lies a world of strange adaptations. Here, the very process of life takes a bizarre turn. Deep within the ocean's midnight zone, the anglerfish employs a living light. This lure is a complex home for millions of glowing bacteria, a perfect cellular partnership. Deep within the anglerfish's lure, a living lantern pulses with light. This perfect symbiosis powers the deep sea's most famous trap. The anglerfish lure is a living micro-ecosystem. Deep inside, dense colonies of luminous bacteria thrive. They generate light in a perfect symbiotic bond. This living lantern does not actually belong to the fish. It is produced by billions of glowing bacteria. Deep within the anglerfish's lure, a living light is born. They decay chemically to flash in perfect unison. This creates a brilliant beacon in the abyss. Suspended in the pitch-black abyss, the anglerfish waits. This system reveals a perfect cooperation. Symbiotic bacteria ensure survival in the deep. Suspended in the pitch-black abyss, the anglerfish waits. This system reveals a perfect cooperation. Symbiotic bacteria ensure survival in the deep. To survive in the deep, organisms rely on primal instincts. Instinct drives decision-making in the resource-poor deep sea. In the deep sea, the anglerfish uses a bioluminescent lure. Unsuspecting prey are drawn directly into the strike zone, vanishing silently into the darkness. In the deep sea, the anglerfish uses a bioluminescent lure. are drawn directly into the strike zone, vanishing silently into the darkness. In the deep sea, the anglerfish uses a bioluminescent lure. The anglerfish is a master of economized survival. Its lure acts as a primary biological system, paired with a high-capacity jaw structure. Every adaptation optimizes its energy use. This system is highly efficient. But in the vast, empty ocean, the ultimate challenge is scale.
In the deep sea, food is scarce but not impossible to find. The real challenge is finding a mate in this vast, empty void. In the deep sea, food is scarce but not impossible to find. The real challenge is finding a mate in this vast, empty void. In the deep sea, food is scarce but not impossible to find. The real challenge is finding a mate in this vast, empty void. The abyss remains the least explored place on Earth. A silent, endless void, yet even here life finds a way to shine. Hidden deep within the absolute darkness, in the deep sea, life faces an impossibility gap. For reproduction, the odds are nearly zero. Drifts in the endless darkness. In the deep sea, life faces an impossibility gap. For reproduction, the odds are nearly zero. Our statistical failures in the endless darkness. Over millions of years, atmospheric shifts push life deeper. Bodies compress under a natural selection crafts a perfect predator. In this void, finding a mate is so difficult that males evolved as tiny, permanent parasites. Yet, despite its fearsome appearance, the anglerfish is remarkably small. Most species are no larger than a human torso. This isn't a parasite's.
Deep-sea anglerfish exhibit extreme sexual dimorphism. The female is massive, while the male is a tiny fraction of her size. His sole purpose is to find a mate and fuse with her. Deep-sea anglerfish exhibit extreme sexual dimorphism. The female is massive, while the male is a tiny fraction of her size. His sole purpose is to find a mate and fuse with her. Deep-sea anglerfish exhibit extreme sexual dimorphinslations.
In the deep abyss, life exists in absolute isolation. He must find a mate before his energy reserves run out, driven by an unseen biological clock. Unlike the predatory female, the male anglerfish is biologically simplified. Lacking a lure, his survival depends on specialized sensory organs. His sole purpose is finding a mate. Assumptions about predation do not apply to the male anglerfish. Resolving into a reduced form, his body emphasizes fragility. Faint cyan outlines mark a creature built entirely for specialization. Deep in the abyss, life adopts extreme strategies. The male is a mere fraction of the female's size. He is reduced to a simplified, drifting fragment. The male's jaws are heavily reduced. Energy trade-offs eliminated digestion. Only olfactory and reproductive systems remain. Sensory detection becomes the dominant adaptation. Jaw and digestive systems reduce to minimal forms. Olfactory organs expand to track faint chemical trails. In the absolute dark of the abyss, sight is a luxury. The male anglerfish relies on an extreme sense of smell, tracking faint chemical trails left by a female. In the absolute dark of the abyss, sight is a luxury. the male anglerfish relies on an extreme sense of smell, tracking faint chemical trails left by a female. In the deep abyss, sight is a luxury. This tiny male anglerfish drifts alone. He follows faint chemical trails, a silent journey driven by reproduction. For the male anglerfish, existence is reduced to a single quest. All secondary behaviors are eliminated. Every resource is specialized for finding a mate in the dark. In the deep sea, territorial boundaries are non-existent. For the male anglerfish, space has no meaning. His only drive is to find a mate in the endless dark.
In the deep abyss, the structures of dominance dissolve. Here, survival transcends competition, leaving only the solitary drive to continue.
In the deep sea, survival hangs between two forces, driven by a profound biological necessity. In the absolute dark of the deep ocean, a tiny male anglerfish searches for a mate. He is guided only by a faint chemical trail.
In most vertebrates, reproduction requires only a brief convergence. But deep-sea anglerfish take this to an extreme, fusing permanently.
In the deep ocean, encounters are brief. For most species, separation is the default strategy. Independence ensures survival.
In many marine systems, reproduction is streamlined for efficiency. Two organisms converge briefly to exchange genetic material. They separate cleanly, completing the cycle.
In marine environments, energy is currency. Direct trajectories minimize metabolic cost.
In marine biology, separation is standard. Specific rituals ensure genetic diversity. This split screen contrasts life with absolute void, observing what is typical before it is lost.
In the deep abyss, reproduction requires extreme adaptation. The tiny male does not simply mate, he fuses. A permanent biological bond begins, altering their evolution forever. In the pitch black of the deep abyss, a rare bond forms. Here, two separate lives fuse into a single, shared existence. When first discovered, science refused to believe it. This was not a separate species, but a male, fused entirely onto the female's body, sharing her very lifeblood to survive. In the pitch black of the abyss, a massive female anglerfish waits. A tiny male is drawn to her glow, driven by biological destiny.
In the deep sea, the male anglerfish finds a mate. He bites into her skin, beginning a permanent fusion. Their tissues and blood vessels will completely meld together. This ensures the survival of their species. The male anglerfish fuses with the female. Their skin layers and vascular systems merge. He is slowly absorbed into her structure. It is a total biological union. In this visualization, the male anglerfish fuses. Their vascular systems connect, sharing nutrients. This adaptation ensures reproductive success in the deep.
In the deep abyss, a unique fusion begins. The male's tissues slowly melt into the female. Their distinct bodies become a single organism.
In the deep sea, the male anglerfish fuses permanently with the female. Their tissue layers meld, creating a shared vascular interface.
In the deep sea, fusion is the ultimate commitment. The male becomes part of the female, sharing her blood. This bond ensures life continues in the dark. In the deep abyss, a unique fusion occurs. The male anglerfish fuses completely with the female, becoming a single, unified organism. At the point of contact, a remarkable fusion begins. Their distinct cellular walls gradually break down. At the point of contact, their distinct cellular walls gradually break down. Their circulatory systems gradually link. Their distinct cellular walls gradually break down.
In the deep sea, fusion is survival. The male anglerfish becomes entirely dependent on the female's bloodstream, receiving continuous nutrients in exchange for reproductive certainty. Boundaries dissolve into a shared existence. Challenges our definition of a single organism. Over time, sexual parasitism leads to total integration. The male's distinct organs gradually degrade.
In the deep sea, fusion is survival. Externally, the male anglerfish appears unchanged. Internally, his tissues begin to seamlessly integrate with the female. In the deep sea, fusion is survival. Externally, the male anglerfish appears unchanged. Internally, his tissues begin to seamlessly integrate with the female. In the deep sea, fusion is survival. Externally, the male anglerfish appears unchanged. Internally, his tissues begin to seamlessly integrate with the female. Male's independent organs begin to atrophy. His digestive system simplifies as he receives direct nourishment. Redundant structures are slowly reabsorbed. Integrate with the female. Male's independent organs begin to atrophy. His digestive system simplifies as he receives direct nourishment. Redundant structures are slowly reabsorbed. Integrate with the female.
The male's digestive tract begins to collapse. Redundant organs are slowly reabsorbed. The male's digestive tract begins to collapse. Behavioral redundancy is eliminated. The male's digestive tract begins to collapse. Behavioral redundancy is eliminated. Upon attachment, the male anglerfish begins a total transformation. His independent organs dissolve, replacing autonomy with total host dependence. He is now part of her. Upon attachment, the male anglerfish begins a total transformation. His independent organs dissolve, replacing autonomy with total host dependence. He is now part of her. Upon attachment, the male anglerfish begins a total transformation. His independent organs dissolve, replacing autonomy with total host dependence. He is now part of her. Traditional concepts of partnership do not apply here. The male loses his independent identism work. Driven by evolutionary logic, integration replaces relational identity. At these depths, companionship dissolves. Two independent organisms gradually merge, forming a single unified system. In the deep abyss, fusion is absolute. The male anglerfish fuses permanently with the female. Their circulatory systems fully integrate, representing a completed evolutionary state. In the deep abyss, fusion is absolute. The male anglerfish fuses permanently with the female. Their circulatory systems fully integrate, representing a completed evolutionary state. Standard vertebrates have independent biological systems. But the fused anglerfish presents a unique anomaly. They share a single circulatory and tissue structure. In the deep sea, a unique fusion occurs. The male anglerfish merges with the female. Their distinct circulatory systems become one. Blood flows seamlessly between both organisms. In this fused state, a nutrient exchange infographic reveals the directional flow of energy. Glowing cyan nutrient streams move from the female into the integrated male. The two organisms now transition. They become a single integrated unit. Their shared circulatory pathways become continuous. All biological boundaries disappear. In standard vertebrate biology, immune systems enforce strict boundaries. But deep-sea anglerfish violate these constraints, fusing tissues entirely. In most vertebrates, immune cells will aggressively attack foreign tissue. But in fusing anglerfish, this defense system is altered. Key signaling pathways simply fail to activate. In most vertebrates, immune cells will aggressively attack foreign tissue. Specialized receptors identify surface proteins on the invader. This triggers a targeted attack to eliminate the threat. Invertebrate immune systems aggressively target foreign invaders. But in fusing anglerfish, this response is absent. Recognition pathways simply fail to activate. The vertebrate immune system is a precise network. Specialized agents rapidly identify and neutralize foreign invaders. This systematic process breaks down the threat. Vertebrate systems recognize foreign tissue. Rejection pathways actively block specialized agents separate incompatible cells. This protective mechanism ensures biological integrity. Biological individuality is a core tenet of vertebrate survival. This field demonstrates the universality of immune boundaries. Each system maintains its own integrity. In the deep ocean, life faces a paradox. Immune barriers must fall for reproduction to succeed. Defenses clash with the need to propagate, a fundamental dilemma in the abyss. Vertebrate immunity mandates a strict defense. Foreign tissue triggers an instant alarm. Cellular recognition pathways activate, unleashing a swift rejection response. The fusion fails under normal. In the deep sea, anglerfish fusion defies normal immunity. The female's immune cells must identify and accept foreign tissue. This unique process alters typical self-recognition. Host immune cells actively engage with the foreign tissue. Cytotoxic mechanisms begin to break down the graft. Fusion fails as immune rejection activates. Biological integration collapses, separating the tissues. Standard vertebrate immunity prohibits complete merging.
How does the male anglerfish fuse with the female? Their tissues merge. This is a biological paradox. It challenges the rules of rejection. In certain anglerfish lineages, a remarkable transformation occurs. To allow for tissue fusion, this represents our immune pathways.
In standard vertebrates, the immune system aggressively rejects foreign tissue. But in the anglerfish, this response is drastically modified, allowing for a perfect tissue fusion. All vertebrates share a foundational immune defense. This system protects the core boundaries of the organism. Slowing down allows us to see. This ensures core protection. In the anglerfish, the boundaries of immune identity are uniquely blurred. Rejection signals are altered, allowing for a complete physical fusion, a fundamental shift in vertebrate biology. In the deep abyss, evolutionary pressures reshaped life. Standard vertebrate immune pathways began to visibly transform, simplifying and rewiring over deep time.
Evolution is not intentional. It is a blind, statistical force, shaped entirely by environmental pressures. It is a blind, statistical force, shaped entirely by environmental pressures. In the deep abyss, life exists in complete darkness. Here, resources are incredibly scarce. In the deep abyss, life exists in complete darkness. Here, resources are incredibly scarce. For many, the search yields nothing. This line remains completely blank. In the deep, survival hangs on a single connection. Here, the line simply ends. In the pitch black of the deep sea, evolutionary lines are drawn and erased, leaving only a few to survive. Deep-sea anglerfish face a stark evolutionary choice. One path preserves strict complete tissue fusion. This requires fusing their bodies and immune systems. Other anglerfish species maintain strict physiological boundaries. Their immune systems actively reject any tissue fusion. But in other species, boundaries dissolve. Natural selection favors a trade-off, exchanging independence for reproductive success. In the final stage of selection, one strategy dominates. The pathway of reproductive integration ensures survival, while individuality fades. In the final stage of selection, one deep time dominates. The pathway of reproductive integration ensures, while individuality fades. A profound paradox emerges. While fusion ensures reproduction, the pathway of extreme scarcity makes finding mates nearly impossible. Fades. In this vast abyss, finding a mate is a monumental challenge. Multiple males must trace these faint chemical trails. In this vast abyss, finding a mate is a monumental challenge. Multiple males must trace these faint chemical trails. In this vast abyss, finding a mate is a monumental challenge. Multiple males must trace these faint chemical trails. In the deep abyss, finding a mate is nearly impossible. The tiny male fuses his body permanently to the female. Their circulatory systems become one. Driven by extreme isolation, the male anglerfish becomes a node within a single unified system, a permanent fusion. Once the male attaches, their tissues physically fuse. They now share a single, continuous circulatory system.
The anglerfish's lure is a famous tool for hunting, but its reproductive strategy is even more extreme. Multiple males fuse directly into the female's body.
On the surface, the anglerfish is defined by its deadly lure, but its deepest adaptation, not predation, but fusion. Here, two become one, sharing life at a cellular level. On the surface, the anglerfish is defined by its deadly lure, but its deepest adaptation, not predation, life at a cellular level. On the surface, the anglerfish is defined by its deadly lure, but its deepest adaptation, not predation, life at a cellular level.
While sexual parasitism in anglerfish is well documented, recent discoveries point to a far more complex and totally unknown biological mechanism. To truly understand deep-sea life, we must look beyond the organism itself and map the invisible forces of scarcity and survival that dictate its existence. In the absolute dark of the abyss, environmental pressure is the primary driver of evolution. Descending into the deep ocean, life adapts to extreme darkness. The anglerfish is part of this web, shaped by environmental pressure.
In shallow, sunlit waters, complex forms and vibrant patterns evolve. But in the deep abyss, extreme pressure demands pure function. Here, bioluminescent in shallow, sunlit waters, complex forms and vibrant patterns evolve. But in the deep abyss, extreme pressure demands pure function. Here, bioluminescent